Okay, welcome to Lecture Chaos, our podcast lecture series in chemistry. And we are so glad, we are so excited. We are in Puerto Rico filming for the first time. And so this is definitely a treat, this is definitely an honor, this is definitely a privilege. Bienvenidos to all those in our Spanish speaking audience. So, this is going to be a preview of the book that we worked hard on, and this is going to be a general overview of some high school chemistry concepts. So this book, as you see here, this was a beefed up version of the chemistry book that was written in 2022 and refined in 2023. This book involves a lot of detailed explanations to chemistry curriculum, especially the high school chemistry curriculum, and it covers our wide range of GCSE topics, BGCSE and GCSE chemistry content. So, as you can see here, we have forwards by some leading figures in science, Dr. Langa, and a forward by Deputy Permanent Secretary DeVoe from the Bahamas Ministry of Education. Um, so yeah, this book goes into a great bit of detail. It discusses, we have a particular set of aims and objectives. Why is chemistry important? We'll discuss a few things for a while and introductory ideas and really give you overviews as to what's going on in the book. Hopefully, feel free to purchase a copy. Hopefully we can get this book integrated into the school system because the intention is that 50% of the revenue from this book will go back to the schools to help with science lab development, especially in the Bahamas. So that's one of the big pushes or big aims and intentions behind the design and even the creation of this book. So aims and objectives. So that's forward by Dr. Langer, forward by Deputy Permanent Secretary DeVoe. This book, of course, is dedicated to my parents, Dr. Ferguson, my sister Darissa Ferguson, my brother Attorney Wilfred Ferguson, and his wife Tarika Ferguson. So yeah, the goal of this book is it's designed to be a timely installment in high school chemistry. It allows for the engagement of students early in their high school careers by presenting the chemistry concepts using underlying narratives about the Bahamas. So basically, the book takes place on Grand Bahama Island and you interweave stories of people as you teach chemistry concepts, and you integrate stories of places as you explain chemistry ideas. And it's taking place in the Bahamian culture and context. So the aims and objectives of this book: to develop curiosity, to create an appreciation for chemistry, to support the idea that chemistry is coherent. There's a underlying constitution behind chemistry ideas. Some may say that it's really tied into Coulombic ideas, Coulombic forces, Coulomb's law, the Chatelier's principle, some of the pillars in chemistry thought. The idea of quantum chemistry, those ideas, quantum chemistry, Coulomb's law, Chatelier's principle, Gibbs ideas, all of those things, Helmholtz, all those ideas. To support the idea, but in this book, we discuss primarily the ideas associated with high school chemistry content. So support the idea that chemistry is coherent, support the development of STEM skills, so critical thinking skills that involve science, technology, engineering, and mathematics. To develop techniques for solving STEM problems, to support science communication, to encourage students to apply knowledge, and encourage students to appreciate chemistry. So we are using the 5-year approach in the design of this book. This book is a practical example of the 5-year approach. So we're engaging the students. Students are engaging with the narrative as well as the animations that didactically explain the high school chemistry concepts. And students can further engage with what-if scenarios where the story or location is recreated in the classroom. Added to that, there are also questions that result in more inquiry in an effort to make this textbook suitable and immediately useful for the Bahamian and wider international context. We've adapted the aims and objectives of farmers. So what we want to do is we want to maintain, stimulate, and sustain curiosity, interest, access, and enjoyment of the environment through studying chemistry and its applications. We want to foster an appreciation of the scientific, social, economic, environmental, and technological contributions and applications of chemistry. We want to show that chemistry is a coherent framework of knowledge, foster the development of skills, develop techniques, ensure students can follow instructions, provide suitable knowledge, foster the development of relevant skills for communication. Also, we want to explore how students investigate the chemistry phenomena using prior experiences and knowledge of the scenarios of the fundamental ideas of the chemistry concepts. Also, as students identify with the common scenarios with field trips, associative frameworks are provided, which allows students to explain the chemistry phenomenon and acquire new knowledge that can be applied for problem solving and in assessment scenarios. Elaborate. So we talked about the explore, explain, so engage, explore, explain, elaborate. As the scenarios and field trips progress with the development of the concepts, students are able to reflect and elaborate on their personal learning development and apply the chemistry knowledge and problem solving skills to new chemistry assessment situations, which will deepen and extend their knowledge base. To evaluate further, students reflect on the ideas learned through this innovative concept development strategy involving the method of loci, so memory palace basically, concrete conceptual development, and other visual learning strategies. They also reflect on their knowledge and learning processes. This is adapted from the work of Bybee and Landes. Okay, so yeah, so knowledge and understanding, handling information and problem solving. This is designed to help students attack these questions. So basically, think of Albert Eschenmoser, Percy Julian, Dorothy Hodgkin. Think of Marie Curie. Think of yourself. Chemistry can be for the brave and the curious, the bold and the learner, and even for those who are beginners. Chemistry is a pathway to research, medicine, and science policy making, environmental science, manufacturing, food science, drug design, and many more interesting and exciting careers to choose from. Chemistry is a very important part of everyday life. It is the study of structure, property, and the composition of matter, and the interactions associated with it and its changes. It spans a basis in which there is physical chemistry, which includes the laws, principles, theories, and computations associated with the small, so femtometers and large-scale changes. Analytical chemistry involves the characterization and measurement of matter using analytical instrumentation such as spectrophotometers. Biochemistry is a study of the chemistry of living things. Organic chemistry is hydrocarbon chemistry. Inorganic chemistry is centered around the chemistry of metals and other compounds. It also involves chemistry of compounds that are not made from carbon and hydrogen primarily, but from metals and non-metals. So it is heavily used in everyday life. Chemistry is necessary for many professions. It provides the observer the capacity to quantify and observe the characteristic properties, of non-living matter, and new substances. Second, it is important because it involves the study of a variety of changes. The changes in chemistry can be examined and analyzed at different magnitudes and classified as either physical or chemical. For example, iron oxidizing to iron oxide, otherwise known as rust, that's a chemical change. Silver tarnishing or silver reacting with acids, that is a chemical change. Of course, ice melting is a physical change. Chemical changes can be classified as reversible, generating, conserving. Chemical or physical changes can be classified as that. So why is it important? It is important because it's used in everyday life. So the overviews. What we want to keep in mind is that in this book preview, basically, a book launch, things we want to keep in mind is that there are separation techniques used in chemistry for the purposes of separation, purification, tests for purity, and measurement. Those tests for separation of mixtures and purification of substances involve crystallization, so you're forming crystals, distillation, so you're separating liquids based on their boiling points and composition to form sub or subfractions. Or you can have fractional distillation, that's what I was explaining, filtration, centrifuging, decantation, and chromatography, which can be in the format of solid chromatography, paper chromatography, or column chromatography with silica. Moreover, there are different parameters that can be measured using different techniques in chemistry, such as mass, temperature, volume, time, and length. So, nature of matter. The nature of matter involves several ideas. The kinetic theory, the study of elements and compounds, pure substances, atomic structure, and bonding. The kinetic theory involves the idea that matter is made up of smaller units, such as atoms, and those atoms ideally are in constant rapid motion and collide elastically. So those are the ideal assumptions made in KMT, kinetic molecular theory. Also, kinetic theory also states that temperature is related to kinetic energy, and it is the average kinetic energy of a group of particles. Moreover, matter exists such that its particles undergo random motion in suspended states, i.e. Brownian motion, movement from high concentration to low concentration, i.e. diffusion, and movement from low concentration to high concentration using energy. So, active transport. Furthermore, matter exists in several phases, namely solid, liquid, gas, and even plasma. For every phase transition from solid to liquid to gas, there are specific named phase changes that result in heat energy release or absorption. Meanwhile, for the gas phase, ideally, there are laws that relate pressure, volume, temperature, and amount of substance. The pressure and volume are also specific to whether it is the standard temperature and pressure or room temperature and pressure. Additionally, there are pure substances which can be described as being made from one type of atom, i.e. element, or multiple types of atoms bonded together, i.e. compounds. For those pure substances and their component atoms, there have been numerous scientists who have developed the ideas that describe atomic structure. Niels Bohr, J.J. Thomson, James Chadwick, so Niels Bohr, Bohr model, J.J. Thomson, the electron, James Chadwick, the proton, Ernest Rutherford, his model, and also atomic mass, John Dalton, so Dalton's atomic theory. We'll discuss that a little bit later. With the group of pure substances as observed on the periodic table, there are different types, such as metals, non-metals. So you have your group 1 alkali metals, group 2 alkaline earth metals, group 3 through 5, group 3 through 6, your non-metals, slash metal, and includes some metalloids, bisegas, antipo. And then group 7, your halogens, group 8, your noble gases, group 5 is your chalcogens. So a number of groups that are organized in the periodic table, and periodic table basically applies the idea that when we arrange elements based off of their periodic number, certain trends are observed based on in terms of like ionization energy, atom size, ion size, electronegativity, electropositivity. All of those things are applications of the ideas we discuss in this book. So the mole concept and the periodic table of element concept. So bakers use the dozen, chemists use the mole. The mole is the chemist's equivalent of the dozen. It describes the number of a group of particles, and the term mole refers to 6.02 times 10 to the 23rd number of particles. Stoichiometry calculations are built on the principles tied to the law of conservation of mass, which says that the total mass of the universe is constant. Moreover, the empirical formula and molecular formula are ways of describing the chemical structure of the substance. Also, molar mass and molar volume are different, especially since molar volume is conditional on whether it is standard temperature and pressure or room temperature and pressure. So we also talk about acids, bases, and salts. This book goes through the entire gamut of high school chemistry. The link will be in the description. Published on Amazon. So for acids and bases, you have your Arrhenius definition, which is centered around hydrogen ions being released by acids or hydroxide ions being formed by bases or alkali. You have your Bronsted-Lowry definition, the release of a proton by an acid or acceptance of a proton by a base. You have the Lewis definition, which involves release of an electron by a base or the acceptance of an electron by an acid. So we go into great detail in discussing these ideas. We discuss the speed of reaction, redox reactions, the periodic table, metals, non-metals. We go into great detail. Again, chemistry is definitely worth the investment and worth the initiative too, to support this book project, because 50% of the proceeds go back to helping the schools. So we are working on getting it reviewed and potentially or hopefully, preferably integrated into the school curriculum. Social, environment, and economic and technological applications of chemistry. And then we discuss some more ideas. Discovery of atomic structure, the periodic table. And then this book, the reason why this book has a degree of novelty to it is it took the practice questions from past BGCSE exams, and I designed an index for it. You have the curriculum category, so what topic it's coming from, the year of the exam, the paper number for the exam and the question number of the exam. So there's four sets of numbers that are indexing every question for about 100 plus questions. And they designed so that you can know exactly which concept the question is coming from, which year the question, which year or paper year the question came from, which paper number, because there's 3 papers for chemistry, and which question number, so you know exactly where to look. So there's definitely a degree of organization and novelty to this book. So yeah, these are the questions. And the book, if you read the book and understand the concepts, you can definitely answer these easily. So introduction and applications of chemistry. So these are the illustrations. So high school chemistry has many objectives, which include stimulating curiosity, appreciation, and helping to develop problem-solving skills. It requires a significant amount of discipline, so fasten your seatbelts for this learning journey. So this will take place in the Bahamas. So you have your separation techniques. You have, as you can see here, so we have illustrations that we designed. All these things were designed by us here. So you have an example of decanting, filtration. We discuss mixtures, go into great detail. So again, you also have organic chemistry. So what is organic chemistry? You have your general chemistry, which gives you an overview of some of the lay of the land, some fundamental ideas associated with the periodic table, composition of matter, inorganic chemistry, basically a few ideas associated with that. It goes into some overview of organic chemistry. So it's like a survey, basically, the landscape of general survey. General chemistry is a survey of the landscape of physical, organic, and biochem. Gives you a brief overview. High school chemistry gives you an overview of general chemistry. So what is organic chemistry? Organic chemistry involves the study of structure, mechanisms, theory, and the leading scientists who developed the ideas, such as R.B. Woodward, Albert Eschenmoser, who recently passed. Lots of big players. You have people like Dr. Brown. You have people like Dr. Barron, Dr. Schreiber. There are lots of, I know two Dr. Brown, one who was an organic chemist and one who is an organic chemist. So there are lots of people. Dr. Williams, lots of big names in chemistry. So some notable ones also include Percy Julian, who did a synthesis work on steroids. So this book, as I said, takes place in the Bahamas, which is an ocean archipelagic nation in the northern western Atlantic Ocean. There's a population greater than 350,000 and is a prime tourist destination. So chemistry requires patience, perseverance, and skills in order to do well. It can be studied using memorization techniques and also learning strategies such as association, rereading, and acrostics. So yeah, so we go into great detail in discussing this book. So I'm just give you a quick scan, then we're going to discuss the nature of matter briefly. So diffusion can be explained as the movement of particles down a concentration gradient without the external input of energy. Active transport is the movement of particles up a concentration gradient with the input of energy. These phenomena, namely diffusion, is a consequence of the kinetic molecular theory of matter, in that particles are in constant rapid motion, interacting with elastic collisions. Additionally, diffusion is dependent on the physical state of the substance and the temperature of the substance. The figure below shows an example of diffusion. And you also talk about Brownian motion, which is a phenomenon that supports the KMT, or kinetic molecular theory of matter, in which specific particles in a homogeneous phase, water or air, move randomly. An example of Brownian motion is pollen in water. So there are also some advanced ideas. You have IMFs, so intermolecular forces, such as hydrogen bonding, which play a large role in water's vapor pressure and anomalous properties, it being less dense at its freezing point than at 4 degrees. Moreover, gases have particle arrangements that have far greater distances when compared to liquids and solids between the gas particles. The particles can be atoms, molecules, ions, or in general, compositional units of the substance being referred to. So phase changes also occur with different physical states of matter. Phase changes that occur typically involve the rearrangement of particles that compose a substance undergoing the phase change. Specifically, the intermolecular forces are weakened or overcome in order to rearrange the physical state of the substance undergoing the phase change. However, the bonding arrangements of the substance, i.e., ionic bonds and covalent bonds, remain the same. Moreover, the melting points and freezing points are pressure dependent and occur at specific temperatures for specific substances. So there's a high degree of technical accuracy with this content. A lot of work went into this book. So Dalton's ideas, so let's talk briefly about that and then we'll wrap for today and just show you a quick overview of the book, and that's as far as we will go. Hopefully you can purchase a copy and see the whole book for yourself. And you also support the initiative because 50% of what you use to purchase a book goes back to helping schools in the Bahamas. So the atomic theory, and the link will be in the description. The atomic theory originating with Dalton can be divided or envisioned through these descriptors. 1. Composition. All matter is made of atoms. Existence. Atoms exist and they are not easily destroyed or may not divided. Uniformity. All atoms of the same element have generally the same ground state, electron configuration, and nucleon distribution. Diversity. Different atoms have different properties. Reactivity. Atoms can combine and their combinations can be described using discrete numbers. So yeah, so as you can see through the book, there is the integration of not just concepts and explanations, but visuals, cards, things that can be adapted in the learning classroom, um, illustrations, and places too. So for differentiated instruction, this book is an example of a tool that can be employed in that because it can reach different learners. So you have practical examples of the calculations, advanced reads for those curious in learning more, your practice questions. It basically is a full package. And then to top it off, as you progress through this book, to top it off, even with the places, like we go from Cooper's Castle to Naran to Tano Beach, and we discuss different concepts at those places, acids and bases, non-melds. Even at the end of the book, after we've discussed all of the content, at the end, so it's total page count of the book in its entirety is 415 pages, but even at the end of the book, we have a workbook which allows you to practice filling in the ideas so you're able to reinforce the concepts by filling the blanks in. So this is definitely a book that a lot of thought went into to make sure it became a funding mechanism to help improve schools in the Bahamas. So uh hopefully you're doing well, hopefully all is well. This again is LectureCast, which are with our sister podcast, the New Chemist podcast. So we definitely, the overall intention of these things is to make an impact in education, to strategically assist people in learning the content, provide tools so people can empower themselves and learn STEM, learn STEAM ideas. So hope all is well, hope you're doing well, and this is the end of this episode.